Hi everyone, welcome back. Today I want to talk about one of the most important concepts in system design, that is the CAP theorem. So if you're actually preparing for any of the technical interviews, then understanding CAP theorem is kind of crucial, and it's not just for the interview's sake, but also for you to build any scalable and fault-tolerant application. It is very mandatory to know. Okay, so I'll be explaining the CAP theorem in a very easy understanding way, and by the end of this video you'll have the solid understanding of it and then how it applies to the real world distributed systems basically. So sit back and relax, let's dive into the world of the CAP theorem. So let me start with writing what is this. Okay, sorry for that. CAP. So what does this cap mean? Is it some kind of a hat that I keep on head? No, it's not. So it is actually three terms, a combination of three terms. The first C stands for consistency, and A stands for availability. Okay, and the P stands for partition tolerance. Okay. This is what the CAP theorem means. So what do I mean by consistency and availability, partition tolerance, if I'm talking about the distributed systems, right? So at a time, this CAP theorem states that at a time any distributed system can have maximum two of these factors available for the system. Basically, it means like only two of these factors will apply to a distributed system, not three. Not three of them will not stay together in a distributed system. That's what it means, the CAP theorem. So let's understand deeper into what is consistency, what is availability, what is partition tolerance, right? So if I'm talking about consistency, and then it's make sure that all the nodes are having the same data at the same time. That's what the consistency is. So in other words, I can explain to you in a better way, something like we have N1 node here, you have N2 node here, you have N3 node here, and then this is the client that you are fetching the data from these nodes. This is a distributed system. So if let's say a write operation has happened here, okay, and after that, after write operation has happened, I try to fetch some data from this distributed system, and then in the first request I get the response as A. Okay, in the second time when I do it, I get the response as B, but I am fetching the same resource. Only one write operation has done before these two fetching of the response. Only one write operation is done, but still I'm getting two different data, which means like my system here is not consistent, right? So if I get the response as A here as well, then I could say that my system, my distributed system, is consistent, which means like whatever the data I write to my system, it is going to be applicable. It is going to be, it is going to be the same data available in all the nodes. That's what the consistency means. So for this, what can you think of the real life example, right? So let's say you have a banking system, and then you think of a bank balance basically, and you did a transaction, you had deducted some of your balance, and then this has to be updated in the nodes, right? So we do the write operation saying that, hey, you go and update my balance inside there. So I go and update in all of this, and then let's say if I don't see the deducted balance whenever I try to see my balance again, then it means that my system is not consistent, right? So this is what you can think of whenever the consistency word comes into a distributed system. When you have to explain to someone, you can do this. You can do it in this way. So now coming back to the availability, this is also one of the concept, right, in CAP theorem. So the thing is like, even if some of the operations or some of the data centers that these servers are being stored at, the data is being stored in the servers, if one of the system fails as one of the node, few of the nodes, not one of the node, few of the nodes, even if the few of the nodes fails, I should still get the response for my resource that I'm trying to fetch. That's what this availability means. So it's like even if let's say we have N1 node, N2 node, N3 node, and then I have the client here, and I'm trying to fetch the server. So due to some disturbance or some network problem, these N2 and N3 nodes are down, and even if this happens, I should still be able to get the data. I should still get the response. So from N1, right? So that is what the availability means. So in order for your system to be more available, you have to build as many as nodes. I mean, it's always like, in order, I mean, what happens if the other nodes also fails, right? So yeah, the availability factor will not be there if all the nodes are down. So that is why, like, you can think of this example like let's say you are using some cloud storage service, right? So there are a couple of data centers for it which have many nodes. So some 10 nodes it has overall, and 5 of the nodes reside in 5 of the let's say we have 10 nodes, and then 5 of the nodes resides in one data center, and 5 more nodes in another data center. Okay, let's say due to some earthquake or some natural disaster, this entire data center is destructed, like it's gone, demolished, or something has happened, and then still I should be able to get the data, right? Because I have another data center available. So which means like the system should always be available for me to get my resource from it. So you understood this availability thing as well. Now let's go back to let's go back to third one, that is partition tolerance. What is partition tolerance? This is some kind of tricky one. People will tend to understand what is consistency and availability. When it comes to partition tolerance, they might have they have some kind of difficulty. So what does this mean? So it is a property of the distributed systems which makes sure that the system can continue to operate despite the failure of the communication between the nodes. That's what it means. So you might not have understood. You might have, or you might not. That's N1, N2, N3, and N4. These are the distributed system nodes that are present. Okay, and all these communicate with each other, right? Whenever some write operation or whenever some write operation happens to the N4 node, let's say, this is going to say that, hey, I got the new write response, so you also update it, you also update it, you also update, like that. This communication will happen. So let's say one of this link has been broken. Let's say this link has been broken. So there is no connection between N2 and N4. Okay, if this happens, so it's like, even in this situation, the system should be tolerant. Tolerant means it has to be very tolerant to a network failure or some communication gap. Still, it should give me the proper response. And I have written a data here, and then now if I'm trying to fetch the data again from N2, then I should not get a different data. Write operation has happened, right? So this write operation has to update in all these nodes, right? So that is what the partition tolerance is. Like, the partition has happened due to some network issue, and the system has to be tolerant for it, right? So if you think of any of the real life example, let's say a ride sharing app that you can think of, it uses multiple servers, right, to track the locations of the passenger as well as the drivers. So they must maintain this partition tolerance to ensure that the system can continue to function even when the network connection has been lost between few of the servers. So I mean, you understood the partition tolerance as well. So this is some kind of I mean, as I said earlier, only 2 of these things can be achieved maximum. You can't achieve 3 of them, right? So you always have to think of your use cases, system requirements, and then based on that you do the trade-off between these 3 factors. And one more thing is, like, you don't have control over this partition tolerance. Basically, you don't know when the network communication is going to break, right? So which you don't have control over. So you in many situations you always try to do the trade-off between the consistency and the availability, right? So that's it for today's CAP theorem in system design concepts. I hope you found it informative, and now that you have some better understanding of the CAP theorem and why it is important and how it applies to the real life systems, right? If you have any questions or comments, please leave them down below. And if you enjoyed this video, please give it a thumbs up and consider subscribing to my channel for more content like this. Thanks for watching. I'll see you in the next one.